Chance of life on another planet. In the year 2147, humanity's quest to find life beyond Earth had reached a fever pitch. For decades, scientists had scanned the stars, analyzed distant atmospheres, and sent probes to the far reaches of the solar system, but it was on a small, icy moon orbiting Saturn, named Enceladus, that the breakthrough finally came. The Discovery Drive. Elena Vasquez, a brilliant astrobiologist, had spent her career studying the plumes of water vapor erupting from Enceladus's south pole. These gases, first discovered in the early 21st century, hinted at a vast subsurface ocean beneath the moon's frozen crust. Elena had always believed that if life existed elsewhere in our solar system, Enceladus was the most promising candidate. When the probe Aegis 7 landed on the moon's surface and began drilling through the ice, the world held its breath. The data streamed back to Earth in real time, and Elena was among the first to see it. As the drill reached the ocean below, the probe's sensors detected something extraordinary: organic molecules, not just simple compounds, but complex structures that could only be produced by living organisms. "This is it," Elena whispered, her heart racing. "This is the moment we've been waiting for." The first contact. The discovery sparked a global frenzy. Governments, corporations, and private organizations scrambled to fund missions to Enceladus. Within 5 years, a manned expedition was launched. The crew of the Odyssey, led by Commander Marcus Kane, was tasked with exploring the subsurface ocean and confirming the presence of life. When the Odyssey reached Enceladus, the crew descended through the icy crust in a specially designed submersible. As they entered the dark, icy waters, their lights revealed a world unlike anything they had ever seen. Strange, luminescent creatures drifted past the windows, their bodies pulsing with light. Towering structures, resembling coral reefs but made of an unknown material, rose from the ocean floor. And then, they saw it. A massive, bioluminescent organism, unlike anything on Earth, moved gracefully through the water. Its body was translucent, revealing intricate networks of veins and organs. It seemed to sense the submersible's presence and approached cautiously, its movements deliberate and almost curious. "It's intelligent," Elena, who had joined the mission as the lead scientist, said in awe. "It's aware of us." The implications. The discovery of life on Enceladus changed everything. It proved that life could exist in the most extreme environments, far from the warmth of a star. It raised profound questions about the nature of life itself and humanity's place in the universe, but it also brought challenges. How should humanity interact with this newfound life? Was it ethical to study these creatures, or should they be left undisturbed? And what if they were not alone? What if there were other, more advanced civilizations out there? Elena and her team spent months studying the Enceladus ecosystem, documenting its complexity and beauty. They discovered that the organisms communicated through pulses of light and sound, forming a network of information exchange that spanned the entire ocean. It was a living, breathing world, hidden beneath the ice. The future. The discovery of life on Enceladus was just the beginning. It opened the door to a new era of exploration and understanding. Missions were planned to Europa, another icy moon with a subsurface ocean, and to distant exoplanets that might harbor similar conditions. For Elena, the journey was deeply personal. "We've spent so long wondering if we're alone in the universe," she said. "Now we know we're not, and that changes everything." As humanity looked to the stars with renewed hope and curiosity, one thing was clear: the chance of life on another planet was no longer a question, it was a reality, and it was only the beginning. Epilogue. A message from the stars. Years after the Odyssey mission, a signal was detected from a distant star system. It was a repeating pattern, unlike anything natural. As scientists decoded the message, they realized it was a greeting, a welcome from another civilization. The universe, it seemed, was far more alive than anyone had ever imagined, and humanity was ready to take its next steps into the cosmos. The ripple effect. Humanity's new horizon. The discovery of life on Enceladus didn't just change the scientific community, it transformed humanity. The confirmation that we were not alone in the universe sparked a wave of curiosity, innovation, and existential reflection, but it also brought challenges, both practical and philosophical, that no one could have anticipated. The global response. The announcement of life on Enceladus was met with a mix of awe, excitement, and fear. Governments around the world convened emergency meetings to discuss the implications. Religious leaders grappled with the theological questions it raised. Was this life part of a divine plan, or did it challenge the very foundations of faith? Meanwhile, the public oscillated between wonder and anxiety. What did this mean for humanity's future? Were we prepared to share the cosmos with other forms of life? Protests erupted in some cities, with people demanding that Enceladus be left untouched. We've already damaged Earth, one activist said. We can't risk contaminating another world. Others, however, saw the discovery as a call to action. This is our chance to learn, to grow, to become something greater, a prominent scientist argued. The United Nations established the Interplanetary Ethics Council to oversee all future missions to Enceladus and other potentially habitable worlds. The Council's first directive was clear: do no harm. Any exploration had to prioritize the preservation of extraterrestrial ecosystems. The Enceladus Research Colony. Within a decade, a permanent research colony was established on Enceladus, dubbed Elysium Station. It was a marvel of engineering, built to withstand the Moon's harsh conditions while minimizing its impact on the environment. The station housed scientists, engineers, and diplomats from around the world, all working together to study the subsurface ocean and its inhabitants. Elena Vasquez, now a global icon, led the research efforts. Her team made groundbreaking discoveries about the bioluminescent organisms, which they named luminaries enceladensis. These creatures, they learned, were part of a vast, interconnected ecosystem that relied on chemosynthesis rather than photosynthesis. The towering reefs were colonies of microbial life, similar to Earth's extremophiles but far more complex. But the most astonishing discovery came when the team detected what appeared to be artificial structures deep within the ocean. These structures, made of a material unlike anything on Earth, seem to serve a purpose beyond mere survival. They're not just surviving down there, Elena said, they're thriving, and they're building. The First Contact Protocol, the discovery of potential intelligence among the luminaries, raised urgent questions. How should humanity communicate with them? Was it ethical to interfere with their development? The Interplanetary Ethics Council established the First Contact Protocol, a set of guidelines for interacting with extraterrestrial life. The protocol emphasized caution and respect. Any attempts at communication had to be non-invasive and based on mutual understanding. A team of linguists, biologists, and xenopsychologists was assembled to study the luminaries and develop a means of dialogue. The first attempts at communication were tentative. The team used black pulses and sound waves, mimicking the luminaries' own methods of interaction. Slowly, painstakingly, they began to decipher a rudimentary language. The luminaries, it seemed, were just as curious about their visitors as the humans were about them. The wider universe, the discovery of life on Enceladus reignited humanity's passion for space exploration. Missions to Europa, Titan, and even distant exoplanets were fast-tracked. The Odyssey 2, a state-of-the-art spacecraft, was launched to explore Proxima Centauri b, a potentially habitable exoplanet just 24 light-years away. Meanwhile, the search for extraterrestrial intelligence, SETI, received unprecedented funding. Radio telescopes scanned the skies for signals, while AI algorithms analyzed the data for patterns. And then, in 2162, it happened. A signal was detected from a star system 12 light-years away. The signal was a repeating sequence of prime numbers, a universal hallmark of intelligence. The world held its breath as scientists worked to decode the message. When they did, the results were staggering. The message was a greeting, accompanied by a map of the sender's star system. It was an invitation. The ethical dilemma, the detection of an intelligent signal, sparked a global debate. Should humanity respond? If so, what should we say? The Interplanetary Ethics Council convened an emergency session to discuss the implications. Some argued that reaching out could lead to a new era of cooperation and understanding. Others warned of the risks, citing humanity's history of conflict and exploitation. Elena Vasquez, now a leading voice in the debate, urged caution. We've only just begun to understand the life on Enceladus, she said. We're not ready for this, not yet. But the allure of contact was too great to ignore. After months of deliberation, the Council approved a carefully crafted response. The message, transmitted in 2163, was simple: we are here, we are listening. The new frontier. As humanity stood on the brink of a new era, one thing was clear: the universe was far more vast and mysterious than anyone had imagined. The discovery of life on Enceladus was just the beginning. It was a reminder that we are not alone, and that our journey into the cosmos is only just beginning. For Elena, the journey was deeply personal. "We've spent so long looking for answers," she said, "but now we know the questions are endless, and that's the most beautiful part." As the stars beckoned, humanity took its first tentative steps into the unknown. The chance of life on another planet had become a certainty, and with it came the promise of a future filled with wonder, discovery, and connection. The universe was calling, and humanity was ready to answer. The cosmic crossroads, humanity's next steps, the confirmation of life on Enceladus and the detection of an intelligent signal from a distant star system marked the dawn of a new era for humanity. But with these monumental discoveries came unprecedented challenges and opportunities. As the world grappled with the implications, humanity found itself at a cosmic crossroads, poised to redefine its place in the universe. The Enceladus dilemma. The research colony on Enceladus, Elysium Station, continued to thrive, but tensions grew as the luminaries Enceladensis began to exhibit increasingly complex behaviors. The bioluminescent organisms, once thought to be simple life forms, started displaying patterns of communication that suggested a level of intelligence far beyond initial assumptions. They began to mimic the light and sound signals sent by the human researchers, almost as if they were trying to learn. Drive. Elena Vasquez and her team were fascinated but cautious. "We're walking a fine line," Elena said during a global broadcast. "Every interaction with the luminaries could have unintended consequences. We need to ensure that our presence doesn't disrupt their ecosystem or their development." The Interplanetary Ethics Council imposed stricter guidelines, limiting human interaction with the luminaries to passive observation. But even this approach raised ethical questions. Were humans interfering simply by being there? Was it right to study another species without their consent? Meanwhile, the discovery of the artificial-like structures deep within the ocean sparked heated debates. Some scientists argued that the structures were evidence of a long-lost civilization, while others believed they were natural formations shaped by the unique conditions of Enceladus. The truth remained elusive, but one thing was clear: Enceladus held secrets that could rewrite the history of life in the universe. The Proxima Centauri mission. While Enceladus captivated the world, the Odyssey 2 mission to Proxima Centauri b was underway. The spacecraft, equipped with advanced propulsion systems and AI-driven navigation, was humanity's first attempt to reach another star system. The journey would take 20 years, but the potential rewards were immeasurable. The mission's primary goal was to study Proxima Centauri b, an Earth-like exoplanet located in the habitable zone of its star. Early observations suggested the planet had a stable atmosphere and liquid water, making it a prime candidate for extraterrestrial life. The Odyssey 2 carried a suite of instruments designed to analyze the planet's surface, atmosphere, and potential biosignatures. As the spacecraft ventured deeper into interstellar space, it sent back stunning images and data, fueling humanity's imagination. The dream of finding another Earth, a world teeming with life, seemed within reach. The signal from beyond, the detection of an intelligent signal from a star system 12 light-years away, continued to dominate global discourse. The signal, dubbed the Whisper, was analyzed relentlessly by scientists and linguists. While the initial message was a simple greeting, further analysis revealed layers of complexity. The signal contained mathematical equations, star maps, and even what appeared to be fragments of art or music. The Interplanetary Ethics Council faced mounting pressure to respond. After years of deliberation, they approved a second message, this one more detailed. It included information about Earth's location, humanity's history, and a collection of cultural artifacts, from music to literature. The message, transmitted in 2165, was a bold step into the unknown. But not everyone supported the decision. "We're revealing too much," warned Drive. Raj Patel, a prominent astrophysicist. "We have no idea who, or what, is out there. This could be the greatest mistake in human history." The rise of the cosmic generation. The discoveries on Enceladus and beyond inspired a new generation of scientists, explorers, and dreamers, dubbed the cosmic generation. They grew up in a world where the existence of extraterrestrial life was a fact, not a theory. Schools introduced courses in xenobiology, astrolinguistics, and interstellar ethics. Space agencies saw a surge in applications, with young people eager to be part of humanity's next great adventure. Among them was Mia Vasquez, Elena's daughter, a brilliant xenobiologist in her own right. Mia had spent her life immersed in her mother's work. "I grew up hearing stories about the luminaries," Mia said. "Now, I want to be part of the team that unlocks their secrets." Mia's work focused on developing non-invasive methods of studying the luminaries, using drones and AI to observe their behavior without direct human interference. Her research paved the way for a deeper understanding of the Enceladus ecosystem, and the ethical dilemmas it presented, the cosmic crossroads. As humanity stood at the threshold of a new frontier, the choices it faced were profound. Should we continue to explore and interact with extraterrestrial life, risking unintended consequences, or should we adopt a more cautious approach, prioritizing preservation over discovery? For Elena Vasquez, the answer lay in balance. We can't let fear hold us back, she said, but we also can't let curiosity blind us. We have a responsibility, to ourselves, to the life we've discovered, and to the universe itself. The world watched as the Odyssey 2 approached Proxima Centauri b, as the luminaries on Enceladus continued to evolve, and as the mysterious signal from beyond the stars remained unanswered. The universe was vast, mysterious, and full of possibilities, and humanity, for the first time in its history, was ready to embrace them. Epilogue, a message received, in 2185, as the Odyssey 2 entered orbit around Proxima Centauri b, a new signal was detected. This time, it came from Enceladus. The luminaries, after decades of observation and mimicry, had sent a message of their own. It was a simple pattern of light and sound, but its meaning was unmistakable. We see you. The universe, it seemed, was speaking back, and humanity was listening. The echoes of eternity, a new chapter for humanity. The year was 2185, and humanity stood on the precipice of a new era. The discoveries on Enceladus, the journey to Proxima Centauri b, and the enigmatic signal from a distant star system had reshaped the collective consciousness of the human race. But as the universe continued to reveal its secrets, humanity faced its greatest challenge yet, understanding its place in the cosmic tapestry. The luminaries' revelation, the message from the luminaries on Enceladus, we see you, sent shockwaves through the scientific community and the world at large. For decades, humans had observed the bioluminescent organisms, studying their behaviors and attempting to communicate. Now, it seemed, the luminaries were doing the same. Drive. Elena Vasquez and her team worked tirelessly to decode the message. What they discovered was astonishing. The luminaries had developed a rudimentary understanding of human language and technology, piecing together information from the signals and interactions they had observed. Their message was not just a greeting, it was an acknowledgement of humanity's presence, and perhaps, an invitation to deeper communication. This changes everything, Elena said during a press conference. The luminaries are not just intelligent, they're aware of us, they've been watching us, just as we've been watching them. The Interplanetary Ethics Council convened an emergency session to discuss the implications. How should humanity respond? Was it ethical to engage in direct communication with a species that had only just begun to understand us? The debate raged on, but one thing was clear: the luminaries were no longer just subjects of study, they were potential partners in a cosmic dialogue. Proxima Centauri b, a new Earth? Meanwhile, the Odyssey 2 had successfully entered orbit around Proxima Centauri b. The data it sent back was nothing short of revolutionary. The planet had a breathable atmosphere, vast oceans, and continents teeming with vegetation. But the most astonishing discovery was yet to come. As the Odyssey 2 deployed its lander to the planet's surface, it detected signs of movement, large, bipedal creatures roaming the forests. The images, though grainy, were unmistakable. Proxima Centauri b was home to complex, multicellular life, and not just life, intelligent life. The lander's sensors picked up structures resembling dwellings and what appeared to be tools. The creatures, which the mission team dubbed Proximans, seemed to live in organized communities. They were aware of the lander's presence, gathering around it with a mixture of curiosity and caution. "This is it," Commander Marcus Kane, now the mission's leader, said in a transmission to Earth. "We've found another Earth, and we're not alone." The Whisper's response, back on Earth, the mysterious signal from the star system 12 light-years away, the Whisper had finally been answered. The response, received in 2186, was more complex than anyone had anticipated. It contained detailed star maps, advanced mathematical concepts, and even instructions for building a device that could facilitate faster-than-light communication. The scientific community was divided. Some believed the instructions were a gift, a way for humanity to join a galactic community. Others saw it as a test, or a trap. "We have no way of knowing their intentions." Drive. Raj Patel warned, this could be the greatest opportunity in human history, or the greatest threat. The Interplanetary Ethics Council approved the construction of the device, but with strict safeguards in place. The project, dubbed Stellar Bridge, was humanity's first step toward interstellar communication. But as the device neared completion, questions lingered. Who were these beings? What did they want? And what would happen when humanity finally reached out? The cosmic generation rises. The discoveries on Enceladus, Proxima Centauri b, and beyond had inspired a new wave of exploration and innovation. The cosmic generation, now in their prime, led the charge. Mia Vasquez, Elena's daughter, had become a leading figure in xenobiology, working to bridge the gap between humans and the luminaries. Her groundbreaking research paved the way for a deeper understanding of extraterrestrial life, and the ethical responsibilities that came with it. Meanwhile, young engineers and scientists worked on the Stellar Bridge project, driven by the dream of connecting humanity to the stars. Among them was Aidan Kane, Marcus's son, who had followed in his father's footsteps as an explorer. This is what we were meant to do, Aidan said, to explore, to learn, to connect. The universe is calling, and we're finally ready to answer. The echoes of eternity. As humanity stood on the brink of a new frontier, the echoes of its past reverberated through the cosmos. The discovery of life on Enceladus, the journey to Proxima Centauri b, and the enigmatic signal from beyond the stars were not just milestones, they were reminders of humanity's resilience, curiosity, and capacity for wonder. But the journey was far from over. The luminaries, the Proximans, and the beings behind the whisper were just the beginning. The universe was vast, mysterious, and full of possibilities, and humanity, for the first time in its history, was ready to embrace them. As Elena Vasquez stood on the observation deck of Elysium Station, gazing at the icy surface of Enceladus, she felt a profound sense of hope. We've come so far, she said, but this is just the beginning. The universe is waiting, and we're ready to explore it. And so, humanity took its next steps into the unknown, guided by the echoes of eternity and the promise of a future filled with discovery, connection, and wonder. The stars were no longer out of reach, they were a new home, waiting to be explored. The cosmic journey had begun,